We'll consider two charges which are equal in magnitude and both are like charges, that is Q and Q. Separated, say distance is R. R is a separation between them. I'll consider point P, which is a midpoint. It's a midpoint of between the two charges, midpoint. What is the potential at point P? We know because of the charge at A, it is having some potential at point P. Because of the charge at B, it is also having some potential at point P. And therefore, both the potential at point P due to A and B are positive and they are added. Therefore, potential at P is not equal to 0. But if I find a field due to positive charge at A is right side, field due to positive charge point B is once again right side, and both the fields are equal, therefore total field at point P is equal to 0. Therefore, two like charges which are equal, separated by some distance, field at point P at a midpoint is 0, but potential is not equal to 0. Instead of that, if the same charges, magnitude are same, but one is positive, one is negative. Say the distance is R, once again same distance, and we'll consider point P, it is a midpoint. Potential due to charge at A, that's a positive charge, potential is positive at point P. Where a charge at B is negative, therefore potential negative. Both are equal, therefore net potential at point P is equal to 0 because of two unlike charges which are equal, separated by some distance R. But what about the electric field? If I consider positive charge, field is right side. And because of negative charge, field is once again same direction, therefore field is not equal to 0. That means it is having some value, therefore potential 0, but the field is not equal to 0. Same way, if there are many charges, say it's a Q1, Q2 as well as Q3, and we have a reference point to find a field, a potential at due to these charges. So we have to consider distance, say R1, it is R2 and R3. So the total potential because of the three charges at point P is just the algebraic sum. It's a V1 plus V2 plus V3. Reason for algebraic sum is, if the charge is positive, the potential is positive. If the charge is negative, the potential is negative. So therefore, whether the potential positive or negative, just find the sum of that potential at point P, that gives a potential at point P. So these are just the algebraic sum.